Assalamualaikum and good day. Today we will learn a new topic which is Uniprocessor scheduling. So before I start, let me explain the learning outcome of today's class. By the end of this class, you will be able to explain the differences among long, medium and short-term scheduling, understand the criteria in short-term scheduling, and assess the performance of different scheduling policies. So in a multi-programming system, it is a basic form of parallel processing where multiple programs will run on the same processor. So due to this, by having only a single processor, concurrent execution is nearly impossible. So what happened here is the operating system must alternate between the programs to give some processing time to one process and then switch to another process. So basically this is the key of uniprocessor scheduling, which is to assign processes to be executed by the processor over time. We need to have uniprocessor scheduling to allow fair share time, prevent starvation, and to allow efficient processing and also to implement priority among processes. So there are three types of uniprocessor scheduling. The first is the long-term scheduling, medium-term scheduling, and also short-term scheduling. So in the long-term scheduling, long-term scheduling is the decision to add a new process to the group of processes to be executed. So basically, the greater the number of processes in the system, the smaller amount of time an individual process can be executed, thus resulting a competition for the processor increases. In the medium-term scheduling, so it is a decision to add the number of processes that are partially or fully in main memory. So basically, in medium-term scheduling, part of it is a swapping function. Okay, and lastly, we have the short-term scheduling, where it is a decision to which available process will be executed next by the processor. So now, this, as I have mentioned before, this is the aim of processor scheduling, which is to assign process to be executed by the processor so that it will meet the system objectives. So some of the objectives are the response times, throughput, processor efficiency, preventing starvation. So now let us look at the bigger picture of the scheduling, uniprocessor scheduling. So basically, because we have known that scheduling on most systems can be broken into long-term scheduling, medium-term scheduling, and also short-term scheduling. So you can see here in this diagram. This diagram is the state transition diagram. You can see here the short-term scheduling is when you want to decide which process to be selected from the ready queue by the processor, and they will run those selected process. For the medium term scheduling, so it is in between ready state and also the suspend state. So we know that the suspend state is the block state that is residing in the virtual memory or in the hard disk. Okay, so that is the medium term scheduling. So, and in the long-term scheduling is a decision when a new process is created and we want to decide which process to be in the ready state or also in the suspend state. Now, let us look one by one for each of the scheduling categories. So, in the long-term scheduler, so basically, we will need to decide which process to be admitted to the ready queue or the suspend queue. So in this case, long-term scheduling is important to control the degree of multi-programming. So when there are more processes are created, so there will be a smaller percentage of time that each process can be executed. So now, when you create a process from the queue, so you must a decision must be made, whether the operating system take on one or more additional process, and they need to decide which job to accept and turn into process. So the to decide which job to accept and turns into process. I mean, jobs here is the program. Okay, so you can decide based on first come first served basis or based on the priorities given on specific program. So now in the medium term scheduling, so it is part of the swapping function. So basically here you have to see back in the diagram here, the decision to add the process is based on whether the process is partially or fully in main memory. So in here, if in a suspend state, so they will be in the virtual memory which reside on the hard disk, and if it's in a ready state, so it is in the main memory. So this is the decision whether to transfer the process from the virtual memory to the main memory. So basically here the swapping in decisions are based on the need to manage the degree of multiprogramming. So what we have to consider here is the memory requirements of the swap out and swap in process. And finally, we look at the short-term scheduling. So short-term scheduling is also known as the dispatches. So this is the scheduling that which we execute most frequently. So in short-term scheduling, so it will invoke when an event occurs that may lead to the blocking of the current process, or that may provide an opportunity to preempt a currently running process in favor of another. For example, if you have the clock interrupts, the IO interrupts, or operating system calls.